Ladies and gentlemen, a very warm welcome to the series of Road to COP26. And this is about batteries today. Our title, Are Sustainable Batteries a Unicorn? And we're proud and delighted to be here at the headquarters of UKBIC in association with the APC, with a very distinguished panel and some very distinguished members of the audience as well. I'm here as a long-term electric car advocate and ambassador. I was driving them back in 2009, IMEVs and C0s, when they were miserable, cold, and did 50 miles to a single charge. But as a car journalist, I thought it was really, really important to embrace this new technology and find out whether it worked or not. And here we are, a decade or more later, and we know it does work, and it works really, really well. I drive a Tesla Model 3 now, and recently drove to France, 769 miles in a day with just 3 charges. So that technology is here and now, and we have an industry, a potential to make this country one of the world leaders in batteries and electric car technology. So let me begin by introducing the Managing Director of UKBIC, Jeff Pratt. Please put your hands together.
Good morning and welcome to UKBIC and this Road to COP26 event organised by the APC. I'm delighted to have such a distinguished panel here today. For my part in the event, I'm going to take you through a quick introduction to the UK Battery Industrialisation Centre. So hopefully, when I click this button, these slides will work. Yeah. Okay, so the first slide you can see on the screen there covers the Faraday Battery Challenge. So the UK Battery Industrialisation Centre is part of the Faraday Battery Challenge. We have 3 pillars. Faraday Institution that works with universities around the UK on initial research in batteries and R&D. The central pillar is funding into collaborative R&D projects, which is governed or organised by Innovate UK. And the third pillar is the Industrialisation Centre here today, which job is really to support companies scaling up their technology and getting to market. On the right-hand side of the slide, you can see we have a box there called the Automotive Transformation Fund. The purpose of this pillar is to incentivise companies to set up in the UK. So the idea is you can start with initial research in the universities, you can pull that through collaborative R&D works into real product. You can then scale that product up and get it to market through UKBIC, and then use the Automotive Transformation Fund to really set your own businesses up. Okay, so where does the Industrialisation Centre sit in the ecosystem? Well, we sort of sat between commercial labs or specialist universities and gigafactories. So we're working towards the high TRL, MRL scale. We're close to the market and we're helping businesses get their products to the market and get going in the UK. Okay, a bit about the facility itself. It's about 20,000 square metres, which is about 3 football pitches. We have electrode, cell, module and pack manufacturing capability here. We can support new processes, new materials, new cells, modules and pack structures. We're here to reduce the risk of commercialisation in the UK. We're open access to any company who's currently in the UK or wants to start a business in the UK. We don't own any IP or challenge for any IP from organisations using the facilities, and we also have a remit to deliver skills around battery manufacture for the UK. Okay, a bit about the facility itself. So we have mixing, coating, drying, calendering and slitting, which is electrode process. We have cell manufacture, both cylindrical cell and pouch cell, and the associated formation and agent. And then we have an agile module and pack facility. And what we mean by agile is it can cope with a variety of sizes and different cell formats to make the modules and packs. In terms of capacity, we're 2 to 3 gigawatts in electrode manufacture, which is quite significant. If I converted that to cars, so if it was leaf cars, that'd be about 50,000 leafs, so it's quite significant. We have hundreds of gigawatts of cell manufacture, so not quite as big as electrode. And then we're capable of about 50 modules a day and about 2.5 packs a day. So some significant volumes if you add that up annually. Okay, a little bit about the operating principles. So although we are part funded by government, there is a fee for using the facility. As already mentioned, any IP generated through this facility is the organisation using the facility, it's not UKBIC. And we operate with secure and confidential practices in the facility. Here, some pictures of the facility now, because we'll be doing tours later, but a lot of the equipment is in the clean and dry room, so you can't see it, so we thought we'd put some pictures in the presentation for you. So great shot of the facility itself, opened by the Prime Minister in July. Some shots of the front room, so we've got reception areas. We've got customer campaign rooms there and the refreshment facilities. These shots are of electrode manufacturing, so you can see we've got mixing, coating, calendaring, slitting, and of course on the right hand side of the slide, the drying oven. Cell assembly in this shot, these ones are cylindrical cell manufacturing equipment and formation and aging. And you can see there's some finished cells at the bottom right. And then just to finish off with the module and pack facilities. Okay, in terms of what we do, so we make to print to enable, so that enable is the enable investment in the UK. We also prototype at scale, so an organisation come to UKBIC and prove quality cost delivery before making their own investment. We do knowledge and skill transfer. We support all the collaborative R&D programs, and we also do some consultancy work. And in terms of sectors, so we mainly up to now have been working with automotive because Faraday one was all around automotive, but we are hoping to push into aerospace, rail, off-highway and marine. All forms of energy storage, so grid, commercial, domestic. Other industrial applications like warehousing, so autonomous robots in warehouses. We work with most of the battery cell manufacturers, and we have a big job to do in the UK to support the growth of the battery supply chain. Okay, that concludes my opening address. So I'm just going to hand back to Quentin now for the panel discussion. So, thank you.
Thank you very much, Jeff. Could I ask our distinguished panel to join me on stage? So that's Jacqui Murray from the Faraday Battery Challenge, James Frith from Bloomberg NEF, John Regnart from the APC, and Graham Hoare, OBE from Britishvolt. Thank you all very much indeed. Right, so are sustainable batteries a unicorn? Could you, in a kind of compact and tabloidy way, tell us whether you agree or disagree with that statement? Graham.
Absolutely, sustainable batteries are possible for the future. Batteries coming out of China at the moment are about 92 kilograms of embedded carbon. In Europe, it's better, it's about 62 kilos. I'm absolutely convinced in the UK we can get to 25 kilos this decade with the supply chain localization that we're taking part in, and is triggered by the rules of origin that the government has put in place.
So that's a yes.
That's a yes.
John.
Completely agree with Graham. Yes, there's so many different sort of innovations that aren't happening sort of 3 to 5 years. In the next 1 to 2 years, dry electrode manufacturing that gets rid of some of the solvents and enables sort of CO2 reduction. There's new chemistries that are coming on, CATL in 2023, talking about sodium ion in certain applications as well, which sort of more abundant materials. Also in the supply chains for like nickel, graphite, and lithium, really reducing the CO2 intensity of some of those key refining of those key materials. And this is all happening at lightning speed and really quickly. That's about 2 or 3 years away.
There's a yes from John. James?
It's a resounding yes from me as well. And I think it has to be if we want batteries to save the world. And I think everyone on this panel would say that that is what they want. Batteries are here to change the world. And luckily, we're seeing that message throughout the supply chain now. So it's going from automotive manufacturers through to cell producers and even into the raw material space. So in the future, batteries will be sustainable and they will save the world.
Jacqui?
So I'm going to be a bit controversial. Why not? I'd say yes if, and I think that the if is if government and funders like ourselves can support people through market failure. So recycling is a really good example. It's a very difficult thing to ramp a business up in when your raw materials, your feedstock to it, aren't yet coming off the market at end of life. So we've got some support to do there, and facilities like the Advanced Propulsion Centre who fund ourselves and Faraday Battery Challenge, we fund, I think together, I'm looking at Ian Constance, the chief exec in the audience, I think we probably funded in the last 4 years over 30 million together, probably more on recycling projects. So I think we have to help companies do it. But then on the other hand, I also think we have to regulate. I think government has to help consumers know that they're doing the right thing. And I think things like eco-labeling, so you see it on washing machines and fridges. I think we have a very clear responsibility to make sure our manufacturers are also doing the right thing and doing what they're saying they're doing.
So a unanimous yes from our panel. Okay, let's just go on. Batteries, Graham, you're making them, or you will be making them in 2023 when the factory is finished. Just tell me, given the energy crisis we've had over the last couple of weeks, batteries, it's not just about EVs, is it? There's a whole new industry of energy storage ready for this country to just adopt, isn't there?
That's absolutely right. And I think in the short term, our focus is clearly on mobility, and it's clearly on electric vehicles. And you know, mobility touches all of us. So it's a really important symbol for our nation and for the nations around the world that electrification is coming. But beyond that, reaching up into the sky, so eVTOL, for example, and into flight, that's at our grasp as well. And technologies that we're developing in the electric vehicle space, stretching into that space is possible. But equally important, if not more so, is down to the ground and static energy storage. If we want to make by 2050 the planet sustainable, we're going to need to be able to manage that short-term storage strategy, and ground-based storage is going to be vital.
John, if you had a message to consumers who are kind of vacillating and listening to all the urban myths and the warmed over yesterday's lunch about EVs, what would you say to them?
I'd say that there is a range of EVs now on the market that can cater for wide different user habits. So you've got the EVs that can do long range. You know, Lucid did the 500 miles EV, but there are more affordable EVs like Zoe and Leaf that can do well over 200 miles, that can fit most driving habits. I think 95% of journeys are under 50 miles, which can cover most different trips. And then there's sort of very urban mobility focused vehicles as well that are aimed at more sort of Gen Z and millennial customers like myself, that are like Citroen Amy, that are sort of two-seaters, very connected, you know, £6,000, that are marketing to new generations. So I think EVs is not only just replacing the sort of business models of the ICE engine, it's actually creating new product segments as well completely.
And just going back to you, Graham, batteries now are going to be completely different, aren't they? Because we had all these compliance cars and their ranges were limited because it was built for a combustion engine, and they put a battery in and it was smaller and heavier. The batteries are always going to be better than they are now, and the range is going to be better and the density is going to be better, isn't it?
Absolutely. So we're working on a number of paths for energy and volumetric density improvements. But we're also thinking, as the volume expands radically, and it is over the next few years, our ability to tailor batteries to these applications that we've just heard about is much more profound. So we can look at the duty cycles of commercial vehicles that require very different battery structures to that of a, let's say, a sports car. And we can engineer those batteries so those use cases are supported more effectively, more affordably. So really the future is going to be in tailoring of these chemistries and these applications so that these vehicles do really set us all free.
So it's a kind of bespoke battery world
Absolutely.
we'll be looking at.
We will.
James, just tell me how important this is, this brave new world of energy storage, of batteries, to the UK. I mean, somebody described it as one of the greatest commercial opportunities since the railways. Do you agree?
I think it certainly is. It's a kind of global revolution that we're seeing now. And actually, at the moment, as it stands, Europe is lagging some of its kind of Asian peers. And so the opportunity is now for Europe to invest and to protect its automotive industry and to really level up and kind of increase the skills of its workforce and to capture some of the kind of value chain that is going to be governing our automotive industry, our power industry for the next 50 plus years. So there is a huge opportunity here. And we are very early on, as Graham mentioned, we're just now at the point where we have the opportunity to kind of tailor batteries for different end use applications. We're also at the opportunity where we can tailor the supply chains. Because we're starting from scratch, we can look for local supply chains that use the most sustainable materials and that bring the most value to a country or a region. So it is a huge opportunity here for Britain, for Europe, and for the world, really, if we want to make the world a better place. And now's the time to kind of invest and really capture that opportunity.
There will be people watching this who say, well, look, the Chinese already had 77% of all the mega factories that make batteries in the world. Jacqui, what happens if we don't do this, if we don't take this commercial opportunity?
So I think actually from a government point of view, we've regulated ourselves to net zero. So I think the stark message is if we don't do this, if we don't look to manufacture here, actually we'll import those vehicles and they'll be made in the rest of Europe, not in the UK. And so therefore we won't get the economic gain from it. So for me, we've got an echo. So for me, it's how do we as the country build on our know-how? Might stop for a moment.
You're reinforcing your message very well.
That's quite fun, isn't it?
Try that again.
Is it gone? We still have some feedback. Okay, so somebody want to switch the speaker?
Can we switch Jacqui's mic off and then you just shout?
Should I help sing? I'm always the one that causes trouble on the panel. Not normal technically.
Okay, testing, 1, 2, 3. Okay, so look, just finish what you were going to say.
Yeah, so if we don't manufacture here, we lose knowledge, we lose experience, and as James said, we can lose the automotive industry, potentially aerospace in the long term, potentially a lot of the manufacturing here. I think we forget how good the UK is at manufacturing. I think we forget how good we are at creative engineering, and particularly at motorsport. We're very good at making things move and providing USP to companies.
So the batteries, or the motor industry, will just move to where the batteries are, which will be abroad. And that means we would lose an £8 billion contribution to GDP.
So you see that anyway. You see that we've been seeing that over the last few years. In fact, I'd probably argue that actually the move to Europe from China of battery production is following the production of automotive. So you can make the argument if the batteries aren't made here, it's going to move back away. And we're going to lose out in the UK.
Can I add something to that as well? I think you're right that the battery industry did follow the automotive industry to Europe, but we've also seen a change over the last couple of years where initially it was about the lowest cost production, and we saw Asian companies moving to Eastern Europe. But we're now in a situation where there are other metrics that people are optimizing for, whether that's low carbon or kind of proximity to the existing automotive industry. And so this is again why now is really a key time within the EV industry to look at actually where is battery manufacturing, or where is automotive manufacturing happening today, and where can we have the kind of lowest CO2 footprint of our supply chains?
Comes back to what you said, Jacqui, about regulation around the EU. All these suppliers can see over the hill that, oh, well, cars are going to be legislated on an LCA basis or beyond tailpipe, and actually the net zero target. So all of the the battery supply chain are now producing to have net zero cathodes, anodes, whatever, and the cells themselves will be produced at net zero, like Graham and Britishvolt are doing as well. So yeah, it's the regulations driving this as well from a Europe and UK perspective.
So I guess the point is the Far East produce volume, but we're still in a transformational change period, and actually we've got to do something different. We've got to create these batteries that Graham was talking about. We've got to engineer bespoke solutions for vehicles, and actually it's not just batteries, it's not just that, it's all of the vehicle. Everything. And how it works for the consumers. So we've got a really exciting moment, because actually understanding how to make them environmentally safe, environmentally low impact is still part of that learning, but we'll get there, and the UK, I hope, will have a part to play.
And you have done a lot of work at Britishvolt on that environmental effect of making batteries, and you can now measure it, can't you?
Absolutely, that's the case. So we spent a lot of time setting the whole company up. The company is only 15 months old, but it's built on the foundations of sustainability, so sustainable supply chains, the sustainable energy that we'll use at the plant up in the northeast and in our Canadian facility. So that the whole ethos is that if we get it right first time, and that's the opportunity for us in the UK, is we can now get it right first time, then we can be sustainable, and we can actually accelerate over those decisions made in Europe 5 or so years ago, which tend to be using dirty energy to generate their product. But with rules of origin literally around the corner, 2027 will go like that. We've got a tremendous opportunity to capture that supply chain and be much more efficient and really set the new bar for the new industrial revolution. So, Britishvolt chose its location very carefully, and not just the northeast, it chose the UK very carefully because of the ecosystem that has enabled lithium-ion batteries to be so innovative in this domain. And really, I think we can accelerate as a community and get these batteries tailored to market faster than our competitors.
And it's nuts, isn't it, to have a consumer thinking they're driving a green car where the batteries have been made in a factory somewhere else that is powered by coal-fired electricity. Those batteries are then put on a diesel boat or a diesel train and taken somewhere else, and the car is assembled in a factory that also uses coal-fired electricity. So, this purity of this virtuous circle of making batteries here in the UK with a low carbon footprint, it'll never be completely zero, but a very low measurable carbon footprint is what we're aiming for, isn't it?
And I think for Faraday, we work across government. So actually one of the things that people perhaps underestimate is how good we are at regulating, for example, or creating standards, or all the things that actually, if we do it well, enable innovation, enable it at a low carbon, low pollution sort of base. And actually that's what we're looking to do. And you can see it sort of playing out, that knowledge of how to do that through low emission zones, through CO2 targets, through net zero. And actually, for me, as an ex-regulator, it's fantastic to work with them at a pace of change that is unprecedented, right? So you need regulatory change in safety and environmental that comes faster than actually the natural pace. And there, we have a meeting quarterly across government with about 45 different departments and arm's length bodies really discussing sustainability.
Okay, I'm going to take a question from the audience. There's one on the screen here, but does anybody here have a question since you've taken the trouble to come? Gentleman there with a hand up, could you tell us who you are? Have we got a microphone? Who you are and what your question is?
Thank you. Adam Chase from E4 Tech. I wanted to ask about the shape of the industry and the shape of the future shape of the supply chain. The pressures that you've described are obviously a sustainability one, but the automotive industry, if you look at it from the perspective of OEMs, they've suffered the biggest leakage of value, or they are suffering the biggest leakage of value out of their economic system by the advent of batteries. And I wonder whether they're going to sustain that, or whether they will start to reach back down the supply chain and take a more vertically integrated picture. And I realize this is a somewhat impertinent question looking at Graham, but you know, what does the future look like for a major OEM, which is basically bleeding value at the moment?
It's a great question, Adam. And the answer isn't that there's no one size fits all. Every car company, every OEM is different, and their route into batteries will be different as well. We see a huge range of alternatives. There'll be supply agreements between companies like Britishvolt and car companies, but we'll see the opposite end of the spectrum, where vertical integration is on an accelerated time frame for those OEMs. But I think the recipe here is flexibility. I think companies like Britishvolt can play a role in all of those scenarios, because you know, we've all spent about 100 years of our history learning how to do internal combustion engines really, really well. We're at the start of that journey for batteries, and I think the great thing about Britain particularly is our ability to collaborate. We're certainly not concerned about OEMs wishing to vertically integrate. I mean, how can companies like Britishvolt support that journey and together benefit? So I think the whole host of joint ventures, alliances, partnerships for development, particularly when companies want to operate in 2 or 3 different regions, how do they do that successfully, maybe with similar chemistries? All of those opportunities exist. So it'll be horses for courses, but a tremendous opportunity for the future. And I don't think that the OEMs will be disadvantaged at the end of this journey. I think they'll be stronger for the journey.
Another question from the audience, perhaps. Seth.
Can I, sorry, my name's Jeremy Rathel from Cornish Lithium. Just wanted to ask the panel to see how you think that the UK shapes up relative to Europe and relative to China in the battery industry. Are we behind? Are we ahead in certain aspects? What's your summary of where we are?
Jacqui?
So, well, John and I work quite a lot on this, and I think this is James's day job. I think the UK it's easy to underestimate how strong we are. I think we've moved very quickly in the last 4 years. I'm very proud of what Faraday has done with our partners. You've got 450 very exciting scientists and researchers in the UK. We have a collaborative research and development sort of ecosystem out there that's really vibrant and really exciting. And actually, last week we had an event with some VCs, and we had a large number of VCs in the room. And batteries, as Graham will tell you, is a long-term, very capital-intensive industry, not perhaps as exciting or as quick to return as something like fintech, right? So you're seeing a real momentum here. So we have this groundswell with us, and actually the reports you see puts the UK sort of up there. And I suspect it's because they are also seeing the UK can collaborate. We can be part of a sort of standardization of being well regulated and doing deals that are a win-win rather than short-term. And for me, if the UK can do one thing, it's take a longer-term view on this, you know.
And your point there, Jacqui, about the ecosystem in the UK being world-class, that's not a statement that can be at all challenged.
No, I mean, it's funny, isn't it? I think I'm a massive Formula One fan, so and Formula E fan, but UK motorsport is a much bigger industry than people realise in the UK, yeah. And that mindset of creating and innovating and changing the world is at a very fast pace.
John? Can I just add, yeah, I think the UK's got a lot of the right ingredients to really build a battery industry. We've got demand from high value products that will require high value batteries, which is a big attraction for the cell manufacturers and the supply chain. There's pockets of excellence in the chemical sector. Having a strong chemical sector is fundamental to having a strong battery industry, and the UK has got that in abundance. We've got Hoare in Wales doing nickel for batteries, and there's Phillips 66 doing precursor materials for anode materials. It's one of the world leaders in that, in the UK doing that. So every point of the value chain, when we go abroad and we talk about the facilities here that we've got at UKBIC, everyone around the world is like, oh my God, that's a really good facility. The German version of this is still 18 months behind until it's, setting up. So you know, we're here doing things and already doing it. So I think there's a lot to talk about in what's going on in the UK.
And correct me if I'm wrong here, battery manufacture abroad, and I use that as a wide description, tends to be quite prescriptive, doesn't it? I mean, it's like Tesla will buy their batteries and under license from somebody else. And there's not the innovation and the research and the development that you, for instance, are doing to make batteries different electrolyte, different cathodes, different anodes, different materials, to make them better, denser, easier to charge, lighter, cooler, that sort of work isn't being done to the extent it is being done here.
Well, I think there's some countries out there that might take issue with that, but I like it, Quentin. I think that's not so much the point. The point is we do it very well here, and can be trusted to do it really well here. I think the other point is there's so much demand coming. I mean, you know, when we started, we used to put hockey stick graphs up, and I used to think, you know, people would challenge you on it, and those graphs have just gone up and up and up. And if you're interested, the OPC website always has, and the Faraday Institution website always has those sort of analyses, and it's just the demand. I mean, I don't think there's ever been a place where the demand is, we're so confident that it's coming, and I think that's where UK starts to play opportunity-wise, that we will be up amongst those world's leaders, and I think that's really exciting.
Okay, I'm just going to.
Just to add to that very quickly, I think the UK has great research. Coming from a research background myself, we do it fantastically. What the UK has been missing in the past is being able to commercialize that research, which the US has done incredibly well. But I think now, thanks to the Faraday Institution, we're actually in a stage where we're seeing more of this battery research reaching kind of commercial or creating commercial opportunities. So I think Jacqui's certainly
was
right
that
on that
somewhere
part.
that can pull through from academic or entrepreneurial sort of companies through OEMs. I mean, that infrastructure doesn't exist in many places, and that's really the exciting bit for the UK.
Okay, let me take some questions from people watching. We had one a moment ago on the screen. Is battery recycling going to be viable? Is it going to be part of the supply chain?
So I'm happy to take this one. We've recently done some work on this. And I mean, in essence, recycling is viable. You can do it. You can get high recovery rates. The costs are not unsustainable, but you do have one big uncertainty, and that is what are commodity prices at the time of recycling, because of course the economics are dependent on the value of the contained lithium, the contained copper, cobalt, nickel. We're in a period at the moment where those commodity prices are elevated, and so actually recycling is economic. But if we look to the future, kind of 10 years down the line, it's hard to say where those commodity prices will be. But I think something that we can be you know, fairly certain of is that the recycling industry will scale. The costs associated with that, with the recycling process itself and the logistics, will come down, and it will improve that business case. On top of that, if you have integrated supply chains, so you're a recycler that is buying used batteries to then put back into your precursor and cathode production, actually, again, you can overcome some of those commodity questions, because it's more about availability of supply rather than spot price dynamics.
Just before you speak, John, I just wanted to flag up to anybody who might be watching that the old wives' tale that the EV battery is something that will last 5 years, and you'll probably have to have 3 in the lifetime of your car. This is not the case at all, and we'll hear in a minute from Rod, who talks about battery recycling. But they are lasting much longer than anybody dared predict, and we see Chevrolet Volts in America, 350,000, Teslas with 400,000, and even Leafs here with 300,000 miles on the original battery pack. So we've discovered that those apocalyptic warnings about battery life just simply aren't coming true, which is a really interesting point. And the cycle of replacement and recycling, it's going to be quite long, isn't it?
Well, the materials involved are so expensive that actually that's a really sensible way to manufacture. I think the question also asked about second life application. And I think one of the problems you've got is when you take a vehicle battery and put it into second life, actually the business case for doing that, how viable is that compared to such expensive materials going back into prime battery production? So there's some bits we don't know, right?
I think what you'll find is sort of the lower value batteries, so your LFP and your sodium ion and your other ones, high manganese, will probably go into second storage to sweat the asset. However, your high nickel stuff will want to be recycled because actually that will be a profit center for the OEMs and the cell manufacturers and stuff. That's how I see the market going.
And presumably you'll be able to use the recycled materials in your fixed energy storage batteries.
Yeah, absolutely. And of course in our virgin product as well, which will be increasingly required.
Okay.
We know that's going to be regulated for as well. So you're starting to see it all come together. It all knits into a picture that's much more sustainable long term.
A final question, which was about the machinery that makes the batteries. Now, this is really, really important. Currently, most of that is sourced from the Far East. What are we going to do to make sure we've got a machine industry for batteries here in the UK?
I can take this. So about 18 months ago, the Tech Trend team at APC actually got the Manufacturing Technology Association and sort of asked that precise question, not just for batteries, but for motors and power electronics, and said, right, how do we get machining manufactured here? Because the study the APC did was actually, because the machinery comes from abroad, in terms of GVA, it kind of takes you 2 or 3 years to recoup the cost back in terms of economic benefit. But if you've got the machine tools here in the UK, that would just go, like, be an instant benefit. And actually what we found from these workshops, there are adjacent industries in food packaging, in traditional stamping, and sort of food mixing as well can be really similar to some of the stuff that you're doing in battery electrode mixing and stuff. So I think what we'll see in the next few years is these adjacent supply chains that for those industries will start to enter the battery market, because the lead times for these machines are just 3 to 4 years, and that will be a bottleneck in actually trying to build all these gigafactories that Europe needs. So it's a big opportunity for the UK.
And I think the UK government, through organisations like Innovate UK, can enable companies like Britishvolt or Envision or other battery manufacturers to come and use the equipment here and work out how they can gain that know-how, that's the one, and gain that toehold in the industry. And that's really what we're looking for. Yeah. The UK does this stuff, it's just doing it in different industries.
And you can do this up there in Northumberland, can't you? And use local talents and local skills to create a complete surrounding industry, making the machinery to make your batteries.
Absolutely. And we're obviously working closely with facilities like this. These are world-class facilities. But actually, they're the platform, the foundation. The innovation can now start as well. So process innovation, new technologies will be born here in facilities like this in partnership with government and industry. So a lot of our sources today are from mainland Europe, particularly Germany and the Far East. But we're absolutely committed to building the bridges with the local supply chains and those adjacencies, and using facilities like that to innovate together. So I think we have a great opportunity ahead.
Good. Right, okay, we're running out of time. So we all agree that batteries can be sustainable. We all agree this is a huge commercial opportunity for the UK, and that government needs to carry on helping and doing the incredibly sensible things that they've done here to grow this industry, because it is a huge, huge opportunity for us to be world leaders. I know I sound a bit nationalistic, Jacqui, but it's really important that we build this new source of energy. So please give the panel a round of applause. You're going to stay here, and we're going to have a presentation from Jeremy Russell, who is the CEO of Cornish Lithium. Jeremy.
So, yeah, my name's Jeremy Russell. I'm the founder and CEO of Cornish Lithium, a company I started in 2016. My background is I'm a mining engineer, but more importantly, I spent most of my career financing mines, studying the commodity markets. And then in 2016, started looking at electric vehicles and thought about the supply chain that was needed. I'm just going to put my timer on, sorry. And I thought, what is there maybe that's been overlooked in the UK? Is there any opportunity here? And realized, listening to or thinking back to a friend of mine who mentioned lithium being identified in Cornwall. So that's really where the journey started. And it's been fantastic to be on this journey for 5 years and see the opportunities that exist in the UK, making discoveries that, in fact, lithium potential in the UK has been known about since 1864. And the potential for one of the areas we're looking at, the St Austell area, has been known about in great detail since 1987. But what we're really talking about, as we've heard from the panel, is the imperative. And without an imperative, nothing ever happens. And really, we've now got, I heard the words industrial revolution being mentioned, global revolution, and global mega trend. That's what we are looking at with this move to electric vehicles. And I think we heard that the UK is innovative and lots of potential and is really embedded into this industrial change that we're seeing as we move toward electric vehicles. But we mustn't forget that at the moment, the raw materials, the nickel, the cobalt, the graphite, the high purity alumina, and the lithium is coming from overseas. And that, if you overlay that with the problems with ESG, you've got a massive problem. You've got a shortage of supply, no doubt. That's why we're seeing a price reaction. There wouldn't be a price reaction if lithium was in plentiful supply. And really, I think what we have discovered in Cornwall is that we do have the opportunity to at least fulfill some of the UK's need for lithium. In fact, the Faraday Institute has highlighted that by 2035, we're going to need 75,000 tons a year of lithium carbonate equivalent, the measure of what goes into a vehicle. And that is a staggering amount. At the moment, it's roughly a quarter of the entire global supply of lithium. So if we don't do something, we're going to be importing all that material, and we're going to be importing the value add that comes with it and the externalizing the jobs that go with it. We're not going to be capturing that supply chain here. So it's very important that we do that. So just to quickly go through my company, we are a private company at the moment. We do try to act as if we are listed in everything we do. So really what we've done is we've recognized the opportunity in Cornwall to supply lithium, and we've used highly innovative technologies, both in our digitization of data, in our processing and everything else. We have an extensive mineral rights agreements package. We've very successfully sourced money from through crowdfunding, and we've also been very grateful for support from the UK government through the Faraday Battery Challenge, through the Automotive Transformation Fund, through the Transforming Foundation Industries and the Getting Building Fund to further our projects. We really do have very strong support from government, which we're very grateful for, and we'd obviously always need more of that. And if anyone's listening to that, that is quite an important thing to take away. But really, we also have strong support from the Cornwall Council and from the local community, who are very supportive. So we are very much focused on sustainable development. The foundation of the company is very much intertwined with ESG and sustainability, environmental consciousness. We've adopted the UN sustainability goals, and really that is very much part of. So my title for this talk was, can raw material supplies and batteries, raw material supplies, be a unicorn? And the answer is they can actually absolutely be sustainable, as the panel's already said about the batteries themselves. So can the raw materials. At the moment, most lithium is sourced either in Australia or China. China's processed with fossil fuels. Australia, the product needs to be roasted to extremely high temperatures before the lithium can be extracted. That's not really the best way to build a sustainable supply chain. Whereas in the UK, our deposits here, we believe we can extract them very, very sustainably. I'll come on to that in a minute. It's absolutely critical that we do develop a raw material supply chain, as I mentioned earlier, because Europe as a whole, which is currently the epicenter of battery gigafactories, megafactories, whatever you want to call them, has no raw material supplies of lithium at all. So the whole of Europe is currently dependent on importing all that raw material. And obviously, as we head into a possibly more and more hostile environment with China, which is regrettable, but at the moment that seems to be the way we're going, Can we rely on them being magnanimous and sending us the raw materials that we need for Europe's battery industry? Possibly not. And obviously COVID has highlighted raw material supply chains need to be rethought. And it is a big issue that Europe has identified this problem, and the European Union is spending a lot of money on trying to encourage raw material development. And if you need any evidence of that, have a look at a company called Vulcan Energy Resources, which is in Germany, which is doing an amazing job and has really caught Europe's attention. We have a very similar situation to that company here in the UK. So really rules of origin, we can't ignore them since Brexit, really are driving how do we get to the rules of origin so that we don't end up paying tariffs on our exports. One of our biggest exports is obviously vehicles. We do need to make sure that we comply with those rules of origin. We do need to see raw materials enter the supply chain from a domestic source. Why Cornwall? Anyone of you who hasn't seen those pictures before, that's some incredible Victorian mining buildings right on the coast. That was in about 60, where the innovation, Cornwall was one of the innovation centres of the UK, certainly, and of the world in mining. Because it is a mining county. It's debatable how long Cornwall's been mining for, but it's about 4,000 years. There's still a very vibrant China clay industry there, mining kaolin, still exporting 600,000 tons of kaolin a year. So mining in Cornwall is not dead. It didn't die out, but the mining of tin is stopped about 20 years ago, but still very much a mining county. And importantly, with that China clay industry is an amazing amount of infrastructure, railways, ports, and other infrastructure, which makes this a very, very compelling case for us to be able to produce from this area. So as you can see, there are big China clay open pits there. You can see various, if you look in more detail, there are railways and everything. So that's why it's so compelling for the UK to develop this industry. The geological advantage, I'm running out of time, but it really is because underneath Cornwall, right from the Isles of Scilly in the west to Dartmoor in the east, is one very large body of what was molten rock, and it's now crystallized out to be granite. That granite is lithium enriched. It's one of only 5 lithium enriched mega granites in the world. We're very lucky in the UK that we have this. So a very exciting opportunity. What have we done? We've developed 2 different extraction methods for lithium. One is in water, which is our first idea, where you're actually sucking water out of the ground. That water is enriched in lithium. And when I first started, everyone thought that I was completely crazy. It turns out that we have the highest grades of lithium in geothermal waters anywhere in the world, which is great and very exciting. And really that goes hand in hand with the development of geothermal power, which is obviously zero carbon, low carbon. So really you've got a very synergistic industry here where you can power it with geothermal power, extract the lithium very, very sustainably. And we're very grateful we got funding from the Getting Building Fund via the Cornwall Council and the LEP to build a pilot plant, which will be finished in March this coming year to demonstrate that. This uses direct lithium extraction. This is a relatively new technology. When I started the company not that long ago, there were only 2 techniques to do this. Now there are over 35 different techniques, and a lot of them actually out of British universities, where we're demonstrating innovation, what we're all proud of. When people start to think about these things, the brains of Britain really get going. And we're very excited about that. We've produced lithium carbonate from that already very successfully. We're also exploring for rock, lithium in rock in that granite. We think we can build a mine and a production facility and be in production by 2025, 26. We've already produced battery-grade lithium hydroxide, and we're accelerating that project very, very quickly. We have built trial plants already, as you can see from that picture, and we're using a responsible extraction method that doesn't involve roasting. That's the most important thing. And really, this is a big chemistry set that very clever chemical engineers would find every day. They just see this as being run-of-the-mill stuff, but before chemical engineers haven't really had to think about lithium extraction. Now they do. So really that's, in summary, looking forward, a responsible company focused on responsible extraction of lithium here in the UK. We're very excited about the potential here. We don't know whether we're going to be able to supply all of it, but we do know that even if we can supply some of it, we're going to capture the value add for the UK, particularly in Cornwall, which needs steady jobs, and we will be able to do that in a responsible manner. So really, I think what I'd say is anyone who's got any questions, you're welcome to ask, but also if you're ever in Cornwall, do come and see us. It's quite an exciting thing to see. It's really some high-tech stuff to look at, and we believe the foundations and the continuation of a 4,000-year history. So thank you very much.
Thank you. I want to sit there and then I'll. So if you've got questions for Jeremy, just keep them until the next session is over. I'd like you to welcome now from European Metal Recycling, Rod Chadwick. Rod.
Thank you. Okay, so good morning. My name is Rob Chadwick, Strategic Development Manager for European Metal Recycling, EMR. So the title of today's event is actually a question: are sustainable batteries a unicorn? And I'll address that question from EMR's perspective as a recycler. So the opposite end of the supply chain from Jeremy. As our name suggests, we're a metal recycler and one of the largest in the world, but we'd rather express our purpose by saying that our goal is to be a global leader in sustainable materials. And that means that we view the transition to electric vehicles as both essential for society, but also a very exciting challenge for us and also a big opportunity. We've talked about business opportunities, and we see battery recycling as a big opportunity for our sector. Conventional end-of-life vehicles are a very important material stream for us, and we already have a very well-developed infrastructure here in the UK to buy those vehicles, process them, and then supply sustainable raw materials on a global scale. And at EMR, we believe that the move towards electric vehicles is going to transform our industry in the years ahead, and it's only the manufacturers and the recyclers who understand that who are going to benefit from it. So I'm going to focus on two aspects of sustainable batteries that are of most relevance to us as a recycler and how we see this as a business opportunity. The first aspect is the demand for and availability of recycled materials, and the second is the cost of recycling. Demand is the easy part. You know, we all know about the UK government's 2030 targets, and we can all see that electric vehicles are selling fast and that the pace has continued through the pandemic. Full battery electric car sales grew 180% in the UK in 2020, in a year when sales of all cars fell by 30% and conventional cars fell by 37%. So electrification is already happening, creating demand for raw materials for battery production. When it comes to the availability of materials for recycling, it looks like the UK should be in a good place, since we scrap more cars in the UK than anywhere else in Europe by a significant margin, approximately 1.5 million per year. So why is that? Well, there could be many reasons, but a very simple and mundane one is that our cars have a steering wheel on the right-hand side, unlike the rest of Europe. So whereas in Germany, towards the later stages of their lives, cars migrate east, never to be seen again, here in the UK, most cars reach end of life in the UK and are available as scrap and source of raw material. So what that means, there are approximately 30,000 end-of-life vehicles every week in the UK that need to be recycled. And the most common example is a 15-year-old Ford Focus. You have that little mental picture. That's what we deal with day in, day out, is 15-year-old Ford Focuses and others. And that 15-year average age is important because it means that the new EVs being put on the road today will be in service for another 15 years. And the materials used to build them won't be available to us until then. So combining the projected ramp up of new EVs with the age profile of end-of-life vehicles shows the transitional lag caused by the step change in technology that we're talking about now. So that effectively primes the pipeline with a source of material for future years. So with a transitional lag locking up materials initially, how can recycled materials make battery production more recyclable, more sustainable at the outset? Firstly, the new gigafactories will produce significant amounts of production scrap, potentially around 10% of production. That creates an immediate source of raw material. And importantly for us as recyclers, it provides the kickstart for the development of a new recycling infrastructure as well. So we've got that 15-year delay. Do we wait 15 years? Well, we don't have to. We have production scrap coming up very shortly that will enable us to build a new recycling infrastructure. Secondly, while the focus is usually on the more exotic materials like nickel and cobalt in the cathode materials, there are other materials used in battery packs which are already available from recycled sources, such as copper, aluminium, steel, and plastics, and they all have carbon impacts. So specifying and maximizing the use of recycled materials will give significant benefits versus virgin from the outset. Many investors and customers are already wary of consuming virgin materials because of the greater carbon impacts and greater habitat destruction. And we're already seeing as a recycler consumer demand driving premiums for recycled materials. Interestingly, which is a big turnaround for us. We're used to selling at a discount to virgin, and we're now seeing consumer pool paying a premium for some materials, particularly plastics. So we've talked briefly about demand and availability of recycled materials. So let's have a quick look now at cost of recycling. So to date, there's been an expectation that the cost of recycling of a full EV pack at end of life is approximately £1,000 to £2,000 per vehicle, which then brings me on to the RECAVAS projects. RECAVAS is a groundbreaking advanced propulsion centre funded collaborative project being led by EMR, and its objective is to deliver a circular electric vehicle battery supply chain for the UK. So it's developing that supply chain. I've just highlighted a key outcome there because a key outcome for us in the project is to reduce the average end-of-life pack disposal cost for vehicle makers, lease companies and last owners to zero. So a very significant change from the current situation. So £1,000 to £2,000 per pack to an average cost of zero. There are three key aspects impacting average cost at end of life. And the first is logistics. At present, there's no recycling outlet for EV packs in the UK, and there's a very immature collection infrastructure. So collections are inefficient with a van nipping around, picking up the odd pack here and there. And export from the UK for treatment is very expensive because of the nature of packs. So we need a UK supply chain to reduce the cost of end-of-life recycling. Secondly, prioritising second life applications through reuse and remanufacture have a big impact on end-of-life costs. The value of a pack used for energy storage, for example, is several times greater than the material value of a pack that's recycled. And redeploying the packs puts them into other useful applications. So we need to develop that expertise. Thirdly, we need to make the reuse and recycling of packs at end of life as easy as possible. Now, there's an incentive for producers to get involved in this, to support design for recycling and reuse, because they retain, at least in the UK and Europe, end of life liability. And the initial design of packs, including their management systems, can have a huge impact on end of life costs. When we get to the stage where we have 30,000 sorry, let me just scoot on that. When we get to 30,000 end-of-life EVs to deal with every week, we need better ways to deal with those packs, more efficient ways, and we need to work with the vehicle makers to do that now. So the RECAVAS project is a collaborative project funded by the APC, as we just said. It involves EMR, Connected Energy, Autocraft, Jaguar Land Rover, Bentley, BMW, Warwick Manufacturing Group, UKBIC, and the HSE. So it brings together a number of key players essential to developing a new supply chain for essential battery recycling here in the UK, combining partners focused on recycling, reuse, and remanufacture with vehicle makers, enabling a dialogue on better end-of-life outcomes. It involves technical expertise of Warwick Manufacturing Group and the safety experience of the HSE. UKBIC are involved in an important role carrying out a life cycle and economic assessment for the supply chain that we're building as a whole, from initial pack manufacture through to end-of-life treatment. So, back to the opening question: are sustainable batteries a unicorn? Well, we don't believe so. Instead, we see battery recycling as an essential and exciting challenge and a business opportunity. We believe that the EcoVast projects will build the supply chain that the UK needs to achieve that. Thank you.
You just stay there and we'll have some questions. So we're going to play musical chairs a bit. You just stay there. And Rod, do we have any questions for Rod first while he's in front of the microphone? Let me begin then, if you're all shy. I guess this is a question you could ask Graham. What is going to make it easier to recycle, if not repair, EV batteries during the process of manufacture? Because you can reduce that carbon footprint, can't you, even more by making batteries easier and more cost efficient to recycle. So what would you say to Graham that you need to have done?
Well, I guess we start with the highest value application in reuse. It's making packs which are easy to adapt to reuse, and particularly its access to the battery management system to allow the condition of that pack to be assessed easily and quickly. So when a pack reaches end of life and comes into us, we need to assess it. We need to know, is it suitable for reuse? Is it going to go for remanufacture, or are we going to recycle it? And accessing the battery management system, rather than having to hack the pack apart to look at the individual modules, is a crucial part of that.
So you could instantly tell from the BMS, decoding it, what life that has had, what's life's left, and how viable the recycling or repurposing would be.
So that's a crucial part of it. And I guess at the other end of the spectrum, then when it comes to, okay, a pack that we can't reuse or remanufacture, how do we make it easy to recycle? Well, that's making it easy to break down and process and give clean output materials. So that's so things like the use of glues, for example, is particularly problematic. Packs which are essentially a solid glued mass.
Yeah, like
really
a Tesla Model 3, where you're trying to separate all these 4,600 cells. It's a nightmare. It is not that I've done it, of course.
Well, there was a little picture there of some poor person who was trying to do that, and that is a problem. So, yeah.
Okay. For people watching here, though, there is this misnomer that we're going to have this great big conical pile of steaming toxic batteries that are just going to be like nuclear waste. This isn't the case at all, is it?
No, well, we don't see it like that. And we see batteries as a source of raw material, basically.
And really, really valuable too.
Yeah, absolutely. Yeah, I mean, much more valuable than many of the things that we deal with in much bigger volumes. So, yes, so yeah, I mean, our life is taking away some discards and turning it into new raw material. And batteries are a big and very exciting opportunity for us.
Which is why you see a used battery pack for a Leaf for what, £5,000-7,000 on
eBay. Yeah, go on eBay today and you'll see Leaf pack for £6,000.
Model 3 Tesla battery packs, $20,000. So you won't be taking them down to the tip anytime soon. Jacqui, you had a question.
I wanted to answer the one that's on the screen down there. It's the question is, how do we manage the chemical elements safely and avoid huge landfill? It's a good question, but what I would say is the battery regulations in the UK currently do not allow any vehicle batteries to landfill.
Yes.
So we're ahead of that game.
So it's a misnomer.
So I think it's always useful for people to hear that. They don't go to landfill. In terms of the chemical elements, we've had some really interesting conversations with lots of different companies. People like the Society for the Chemical Industry. I think it was John, mentioned how strong the chemical industry in the UK is. They have the ability to do that. I've been talking to somebody in a chemical company that's a pharmaceutical one, and actually they're used to recycling NMP, which is obviously one of the solvents everybody's concerned about. And so what you're starting to see is all this work that you guys are doing coming together. And it comes back to Graham's point. Yeah. We have to collaborate. And the reason we have to collaborate is it's complicated.
No, that's absolutely right. I mean, to be frank, as a recycler, we'll start with the valuable, easy stuff first. I mean, we'll do that bit of it. But there are some really interesting technical challenges in there that we need help with. And that's why a collaborative project like RECAVAS is really important, because it puts together people like Hoare Manufacturing Group and UKBIC to help us tackle those more difficult challenges.
Yeah, and if the person asking is really geeky, like some of us on stage and in the audience, they can go and have a look at a standard, a code of practice that we've done with the British Standards Institute on cells and electrolytes, and they can actually look at all the regulation and standards required. And that again came through a load of British engineers and insurers and everyone else really thinking about it.
And that's the environmental aspect of these batteries, isn't it? But there's also safety is a big aspect as well for us. So another exciting part of the RECAVAS project is the involvement of the HSE, the research part of the HSE. Big for a variety of reasons, really. I mean, but the primary one for us is that these packs will be coming out in vehicles across the UK through a network that's probably not well equipped to deal with them. And we don't want other metal recyclers being damaged by that. So we need to put together the codes of practice and the guidance to help the industry upskill. And the involvement of the HSE is crucial in that. But then also, as we're designing our processes with some fairly unpleasant chemicals, we need to make sure we're doing that in a safe way. So again, another key part of the RECAVAS project.
Hi, Ian Constance from APC. Your graph showed your 14-year lag, right? But that says that you go straight from a vehicle to a recycle situation. Yeah. So I wanted to ask you about the second life usage, because surely if you go to a static storage situation, they could sit there for another 20, 30 years.
So the lag was from, first use vehicle on the road to the end of life of the vehicle, not the pack. So you're absolutely right. And a key part of maximising the value of the pack at the end of that stage is its use, is its application in reuse. So yes, it'll have to push that availability of materials back.
Do you see that second life being the next step? And
we see maximising the value through second life as being a crucial part of this, yes.
And do you imagine that will be large-scale grid storage, or will we all have one in our loft?
I think it'll be a bit of both, but there are partners within this project, within the RECAVAS project, who are very much focused on that. So Connected Energy are the specialist partner in the project, and that's their bit of it. So I'll take my lead from the way they see the market developing.
So we could see, it's a really good question, isn't it? We could see battery life, whole life, from car to static for as much as 25, if not 30 years, which is a really, really interesting prospect, isn't it?
Yeah.
Okay, if you've no more, well, you have another question at the back there.
As Jeff Borman from Recyclers, another battery recycler. Hi, Rob.
Hi, Jeff.
I think one of the things that I've been working with take back of lithium batteries for about 8 years now, very small quantities, ramping up into thousands at the moment. But the key thing that we've found is that the reason they're coming back is the BMS failure in most cases. So when you actually come to test that battery or try and take it apart, you don't know the status of that battery, so therefore it becomes unsafe. So one of the key things with the legislation is how you move that battery from a dealership or something like that. And one of the things I really think for the panel and moving forward is how you move that battery under the ADR regulations a sustainable amount, because at the moment you can only move them in 1s and 2s. And Rob, I know you've had some thoughts about that, and my question is, where do you see that going? Doesn't there be a change in the ADR regulation?
I mean, you're right, Jeff. At the moment, it's one of the early stage challenges is that inefficient transport system that's in place. So it'll take a while till we get some a critical mass that makes that sort of transport efficient, which it will do in time. But there'll be this awkward period of time while the regulations make us deal with things in quite a difficult manner. So yeah, a slackening off of the ADR regs would definitely reduce the cost of the activity. You're absolutely right.
Okay, Rod, thank you very much. Jeremy. Now you can come and take some questions. So any questions for Jeremy and lithium? All right, well, one from me, Jeremy. I mean, how large are the potential deposits of lithium in the UK? We know you've got this epicenter in Cornwall, but have we done all the geological stuff for the rest of the country?
There is another company trying to do something in the northeast on lithium in water. I don't know how big that is, but the largest geological potential is in Cornwall because of the big granite that extends from the Isles of Scilly to Dartmoor. So that is a lithium enriched granite. We don't know how much there is in there at the moment, but it has great potential. So more work is needed to be done. So we're looking at, as I said, both the rock potential, which is much more easy to understand, and the water potential as well. But I think that really Cornwall is the epicenter of where there will be sustainable lithium produced. There are some deposits in Scotland, but they're very, very early stage and in very, very sensitive areas. So the good thing about Cornwall is it understands mining. It's part of their DNA. Yeah.
So what message would you say to the government about the potential for lithium mining and production here in the UK? What do you want from them? And Jacqui will be your conduit there.
What do we want from them? I think we want government to realise that this is real, that we need, it's going to be done responsibly. It's not going to be ripping the ground up and destroying things as they did in the past. The government to realise that if we don't build this industry, we're losing out on a very valuable part of the supply chain, and securing that, so that we've actually got, we know where it came from, we know it's done responsibly, and we create the economic value add, jobs, the whole economy, the innovation. That's what we want government to understand, that it is real and it can be done.
And we can create a UK lithium industry.
Absolutely.
With more than enough to supply all the batteries that Graham will be making in Northumberland and exporting to other countries as well.
Well, I can't say that yet, but what I can say is that every ton that we don't have to import is good. So I think we're saying we can produce 10,000 tons of LCE a year. The UK needs 75,000 tons, which is a hell of a lot, by 2035, which is around the corner. So, and the way we're going is probably going to be quicker than that. So we're early days of understanding how much there could be there, but so far what we see is very encouraging.
And your contribution is again another part to making the battery sustainable, lowering the costs, lowering the CO2 emissions, making it here, transporting it economically and sustainably to the place of manufacture.
Absolutely. I think if you're going to, the unicorn of responsible battery supply starts with the raw materials. If we're importing them, they're being processed with fossil fuels, that doesn't work.
It's nuts.
Yeah, it is nuts.
Great. Okay, well, look, unless there are any more questions for a panel, I'm going to call it a day here. Just put your hands together and thank them very much indeed. Also, this has been great. And we need to do many, many more things like this, because I have learned so much today, and I'm sure you have as well. The COP26 program activity continues with 5 more upcoming events. 5th of October, power electronics with contributions from the Department of International Trade, BMW, Rolls-Royce, and others. 12th of October, the focus is on e-machines. 14th of October, investment, rather important. And that's in partnership with KTN, and 19th of October on energy. And on the 26th of October, the series concludes with fuel cells. So thank you to UKBIC, thank you for the APC, and to all our panelists. I, for one, have enjoyed it very much indeed. Thank you. Okay, all right. So look, do you want to sit down and we'll do some. Okay, so look, we've still got some time. Some questions online. What about the raw material supply chain?
Shall I answer that?
Yeah.
So I'm a metallurgist by background. And actually, Graham and I were having a nice chat about rover days a long time ago. I think what we miss in the UK, or we forget in the UK, is we're actually very good at extracting from mined materials through to metal. I think Jeremy mentioned, or somebody mentioned Vale, who nickel, but also there's 2 lithium companies who are in the UK already, who are extracting. There's more here than you think, and actually, I know John probably knows them and has listed them out in roadmaps and worked out how we could do that. You know, there's great work that's done by the Automotive Transformations Fund looking at the entire supply chain in the UK. I personally think there's far more transferable skills and knowledge here than we realize.
A lot of the human capital was accumulated in the UK around mining excellence, and a lot of the processes used to refine nickel and lithium were actually invented in some of the UK facilities and then exported all over the world, as usually happens sometimes. So I think, yeah, you can't underestimate the social capital and the intelligence and the IP that we have in the UK around some of these sort of extractive industries.
We would talk about industrial revolution. I'm showing my age now, but the second industrial revolution was built on the UK being able to make steel, cement, glass, and actually you're seeing that knowledge come through again.
Okay, another question. There's a lot of talk about solid state batteries in the future, but costs seem to be a key obstacle at present. What is the panel's view of the tech and expected time frame to reach the market? I guess this is one for the battery maker. Solid state, no electrolyte, greater density, lighter, much more efficient. When's it coming?
Yes, please, we'll have some of those.
It's already in a Fitbit. They've got a watch, haven't they, that has a solid state battery?
Yeah, so I mean, there are a few projects that are running around the world. I think the one that we are involved in the UK is amongst the leaders. And solid state really does offer a tremendous promise if we can bring it to market. It takes away a lot of the risks that exist, although we all manage those risks very carefully as an industry, both in the products that we produce and in production. Solid state helps with that even further. Energy density significantly enhanced too. So together it is, it's not necessarily the panacea, but it certainly is a significant development forward. So what we're trying to do firstly is work collaboratively in the UK again, in this fabulous ecosystem, alongside a number of universities on a specific project, which we think has huge potential. Our timeframes are around 2027. 27 to the end of the decade, and what we're doing with our facility is making sure that that last phase of that building would be available in that time frame for a solid state facility if that was available. And I think if we can do it anywhere, I think we can do it in the UK.
Okay, so 6 years, Graham, potentially to have a solid state battery that could be commercialized into an EV.
I think between 2027 and 2030, I think it would be realistic to say, if the technology matures, and that's a big if, but that's what the great minds of Britain are working on now, then I think we can industrialize it. It will be the start of a journey, and the batteries we have today, the NMC, LFP formulations will be dominant in that time frame. But we'll start to see a crack of solid state emerging, I think.
Okay, James.
Yeah, so I think that's completely right. You know, those timeframes are generally what the industry is looking at. I think kind of to go back to the question, you know, there's the question of cost today, and actually that's not one of the kind of issues with why we're not seeing it in EVs yet. It's that the technology is still needing to be developed. So we have the solid electrolytes now, they're very well understood. There's a range of different materials that can be used there. But now what companies are really working on is understanding what happens when you put the solid electrolyte in the cell with the cathode material, with the anode, whether that's lithium or silicon or other materials, and how they behave together, and then how you can get those materials to interact to get the performance that's needed in an electric vehicle. And so that's the big challenge. Of course, then once you can see how you can kind of put them together and mass produce them, then cost does become the question. So in general, the expectation is that in most instances, solid state batteries will probably be used in kind of premium segment vehicles initially, cars where actually that higher cost of the battery doesn't impact the overall cost of the vehicle. And then once you start to get scale, as we've seen in the lithium battery industry over the past decade, once you get to a certain scale, the cost comes down enough and you start seeing batteries entering the kind of mass market kind of EV sector. So Bloomberg NEF, we expect that probably comes around 2030 or so. So you'll get that initial commercialization in EVs 2026, 2027, and then it takes a further kind of 3 or 4 years to kind of get that scale that's needed to kind of see greater adoption.
Yeah, so I was just
John.
saying, the work, so APC is doing some work with Faraday on next gen battery technologies that are actually, where should the UK invest in and what are sort of the most attractive ones, and as you would expect, solid state battery is in there. I think with solid state battery, I agree with everything that James has said, but you have to look at, there's so much capital investment that has gone into the existing lithium ion supply chain. So when you see these press releases from solid state batteries, the main thing they say is 70, 80% capital utilization of existing plan, because you need to be able to have almost a drop in with these existing facilities. Otherwise, why would you sort of invest all of this money in lithium ion liquid electrolyte to then make it redundant in the next 5 to 6 years? So whenever you see these announcements, they're always looking at capital utilization of that. And I think that's a key thing. And then with that will bring down the cost as well. And they're very intricately linked.
Okay. Another question. So this is very topical. What lessons can the battery industry learn from and capitalize on following recent events, including but not limited to energy market surges and consumer behavior, panic buying? Well, I'll begin with that one and just say, look, who knew that we had such an insecure and volatile energy supply? And if the recent events can teach us anything, we really do need to do something about it. And this is what it's all about, isn't it? Relying on fossil fuels and gas from Russia, this is not what we should be doing. And we've just got to develop this alternative form of energy that's clean and it's sustainable, and do it as soon as possible. So I think it's a great validation of what we're all doing. Jacqui.
I was going to say, actually, the whole point of Faraday and the Faraday Battery Challenge and UKBIC and Faraday Institution, all these things you've been hearing about, is putting the UK onto the front foot, right? We always got, why did you choose batteries as a thing? And you're kind of, well, actually, because if we didn't make a move, you wouldn't have been able to have this conversation with such depth of knowledge, with such experience about solid state, or about how actually the energy grid in the UK can change, right? Yeah. We always hear it in black and white terms in media. And the reality is we will have a national grid. Some of it will no doubt be gas fired for quite a long time to come. But also what you're seeing now is sort of micro elements. You're going to start seeing EVs contributing to local grids, to a change in the way we work. And for me, it's been a privilege to work with Faraday because we've had the chief engineer from the National Grid working with us on our advisory group, for example. It really has brought together some of those minds to really look at how we can play for the future in the right way.
James.
Can I just add to that on the consumer behavior side? And I think this is a really important one for the battery industry at the moment. There's a very academic debate going on at the moment as to whether different battery chemistries are suitable for the EV industry. There's the two chemistries in particular, one called lithium iron phosphate, LFP, and the kind of then the higher nickel chemistries. And LFP is seeing a resurgence. And people in the battery industry look at it and they say, this provides suitable range, this can work. We'll see more of this in the future. But I think what a lot of people forget is that consumers aren't predictable. And while from a technical standpoint, 250 miles of range may look okay, if consumers want to have 400 miles of range, automakers can't dictate to them. Automakers have to do what the consumer wants. And so I think the battery industry should be aware of that and should not shoehorn themselves into a certain kind of market type and perhaps lose in the end to a competitor who offers what consumers want.
one final point on the panic buying and stuff. So one misnomer that you do hear about EVs is around, well, there's not enough nickel or not enough lithium or there's not enough this in the world. There is enough geological lithium. One thing I would say is what needs to happen is investment along those areas of the supply chain to help scale that up and help meet the demand of the cell manufacturers and the OEMs. And as James said, you've got the LFP and you've got manganese rich, and this is in relation to the fact that in the next 5 years, the economic scarcity of nickel might be if we don't have investment now. So all of these projects looking at further down the supply chain, looking at the lithium supply chain, looking at sort of getting cobalt and nickel out of batteries are all exactly the right things that we are doing in the UK and need to happen to help shield us from those. So in terms of, you know, the battery industry is doing a lot to stop that commodity panic buying, which gets thrown about a lot in the EV industry. But I think there's a lot of foresight in the cell manufacturers and the OEMs to have long-term strategic agreements and stuff to help shield the EV industry from that.
But energy is now going to become increasingly expensive.
Yeah.
Consumers will not wear for £5,000 dual fuel energy bills. And that makes going to your own microgrids with your solar on your roof and your battery storage, your Tesla Megapack, something that is going to be financially viable.
People always ask me what my job is, and I say, well, I'm a civil servant, so my job is to try and get the right stuff to happen for the UK. And because I work for Faraday, it's in batteries on the whole. But I think that's really what you're seeing. And it's difficult at the moment. There's so much noise in media and what's right, what's wrong. But actually, that is what you're seeing. You're seeing a UK growth of offshore. You've seen that for the last 20 years. You can see actually there's a lot of thinking, a lot of thought into how local grids can work, how they can be more interactive. We've sponsored vehicle to grid technology in Innovate UK, for example, that's ready to go. So you're seeing it coming. It's just it's a complex problem. It's not black and white. It's, you know, whenever I see an argument, the answer is fuel cells, it's like the question isn't that, you know, you're answering the wrong question. The question is much bigger than that. And actually all of these things will play a part. It's coming.
But in America alone, the energy storage market a year will be worth $500 billion. And those stakes are really high.
Yeah, really. And actually you're seeing, I think what these volatilities show us is actually how vulnerable we are. I mean, coming from a regulatory point of view, the first time I learned how close our national grid was in terms of how much they produce to how much we demand, that's real moments in terms of
and one little fire in the Kent interconnector and everybody's running around thinking, what are we going to do? Exactly. We can't have that.
But we also miss telling people just how successful things like offshore wind has become. You know, it was set a target, I think, by 2020 to be £100 per kilowatt, I think it was, hour produced, and it was at 40. So actually what you'll see the same, I think, for batteries, you'll see the same for solar.
The grid actually uses less energy on a total basis than it did 10, 18 years ago because of demand side innovations in energy efficiency. So it's been a real, both, you know, the supply and demand question. You can see that through energy, through homes and other things like that. It's not just a supply question, there is also a demand as well.
Okay, our final question. Do we need more UK-based British EV startups? Of course we do. Jacqui.
Of course we do. I think also what we need is to industrialize their innovation and their entrepreneurial sort of activities, business models, etc. in the UK. And actually sometimes it does go wrong, right? So we sponsored lithium sulfur in the UK, and the company, due to COVID and investors, actually went under. And what was brilliant was to see Johnson Matthey buying IP from that and to see all those staff going straight into very high skilled battery jobs across the ecosystem. And so I guess why I'm bringing up failure is because actually it shows that when you've got the momentum, when you've got the ecosystem, it's not just that you have more startups, you have more successful growth of all the businesses, and it's kept more sticky to the UK. You know, I think one of the things we would always argue is that actually Chinese and US and international companies will come and buy UK IP. And actually when you have this level of momentum in the UK, you start to see more of it staying here, because actually it's not just intellectual property, it's also the know-how to exploit it.
Great.
Wow.
Okay. All right. Thank you all very much indeed. Our time is up now, definitely. And there are tours available, are there not? Right, so I, for one, I'm going to put my hand up and accept. You've been wonderful. Again, another show of appreciation for our wonderful panel.